react on the oxygen, which means you need the oxygen to attack the carboxylic acid carbonyl here. And if this is not very available, it is not nucleophilic enough. It's not going to be helped by this catalyst or the high temperature. It's just not going to work. And for that, like you said, you need acyl chloride. You need acyl chloride because acyl chloride is a more electrophilic carbon. So it is stated in the AS syllabus, because I did always print out my syllabus, so that I can always read it whenever. So more electrophilic carbon means the carbon is more delta plus, and therefore it can overcome the less nucleophilic character of the phenol there. And now, if I have phenol, if I want to form ester with a phenol, I need an acyl chloride. So the acyl chloride I'm going to use is this acyl chloride. Do you know what is the name of 2-carbon acyl chloride?
2-carbon will be ethanol chloride.
Yep, that is correct. So, random stuff, they could say, what is the name of the reactant? Then, people could do formula, and then people are like, I don't know, I just know it's acyl chloride, but I could never name it, okay? So I believe that you are well prepared, so that it's all good, and then they can get that. Now, this is a condensation reaction. Condensation reaction, and you will kick out a small molecule. Condensation reaction involves 2 steps. What are the 2 steps in condensation reactions?
First, the chlorine is eliminated. Sorry.
That is not the first step. The first step is nucleophilic addition. Are you aware that it is new in the syllabus starting from this year, that nucleophilic addition and then elimination, you have to know that mechanism for paper 4?
Oh, really? I didn't know that actually.
Okay. Can you take note? Can you take note of this?
Yes, please. I have this.
Okay, 33.3.3. 33.3.3. Yep. So there's on page 46 of the syllabus. So it's under, so the mechanism, okay. So the type of reaction is condensation. The mechanism involves nucleophilic addition and then elimination, okay. So this is under, this is syllabus 33.3.3. So it said describe the addition elimination mechanism. Well, addition, this is AS chemistry. This one is slightly new, okay? So this one happened first, and then this one happened second. So don't say I don't tell you, okay? Because in the older syllabus, this one wasn't really required. It was just state that the reaction involved addition, elimination, condensation. But now they say describe. So I don't know whether they'll ask you to draw or they'll ask you to describe in words. But when it's a mechanism question, there is nothing better than to draw. Okay, so I'm going to draw it. It doesn't matter if you use phenol or if you use normal alcohol, you are still going to get the same mechanism. Okay, all right, now there's my phenol. Now I have my acyl chloride, okay? So focus on the acyl chloride. What do you think is the first thing I should do? So nucleophilic additions. Go on.
Yeah, so the chlorine will attack the CCl bond. Will attack the CCH3?
Nope, it doesn't do that. The first thing is nucleophilic addition. Remember in AS chemistry, when you did AS chemistry, nucleophilic additions, something adds onto the carbonyl. You remember that? Something adds onto the carbonyl. So you must draw delta minus, delta plus, delta minus. Happy with that? That's the first thing you do, yeah?
Okay.
Okay, now the next thing is, you have a lone pair here. It's not very available, but this is extremely electrophilic. The carbon is extremely electrophilic because of 2 highly electron withdrawing group. Nucleophilic additions, nucleophile, electrophile. So be careful, nucleophile, electrophile. So rich attack poor, rich attack poor. From the rich, attack the poor. Happy with that? So that's the first step, yeah? Okay. And then the second step is, obviously in nucleophilic addition, you attack at the carbonyl and then you break the C double bond. Also, that is the second step. Okay, later on you can practice this again, yeah? So I'm gonna draw the intermediate now. So I have an O.
This is nucleophilic addition, I believe, yeah?
It is. It's AS mechanism, right? It's AS mechanism.
Yeah, okay.
Okay. So CH3 and Cl. Happy with that? Oh, and a plus.
Okay.
So no charge and no charge. Plus one, minus one, no charge. Okay. So the next thing that will happen is called elimination. So what happened is, instead of this adding to a H plus, it doesn't do that because it has to do a second step, because the second step is elimination. This is elimination of your Cl minus. So this is delta minus, right? So this is the third step. Give you back the double bond. Give back the double bonds,
Okay.
but carbon can only form 4 bonds. So once I give back you the double bonds, I have to kick out something. So this is the third one. So actually this is like the second step. I'm saying like from the first, the second, then this is the third thing you do, and then you give back that thing back. Are you happy with that?
Yes.
Okay.
And the final product will be?
Probably that is not the final product yet, because you have to show something. You have to show something, okay? I'm going to show you something. The COCH3. So that thing is done. You get the ester. But what did you kick out? You kick out Cl minus, right? You kick out Cl minus. And Cl minus has a lone pair. And you have a H plus lingering around here. So it attacked the H plus. So that means the Cl combined with the H, and then you will get HCl, hydrogen chloride. You agree? Steamy white film. Observation, right?
Yes.
So you get that. But the mechanism is not complete yet. When this take away the H plus, where does the 2 electron go to? It goes back to the oxygen. So when I take a H plus has no electron, I give back the electrons to the oxygen, then the oxygen will lose the positive charge. Does that make sense?
Okay. Yeah. Yep.
Okay. So I mean, this last step is not extremely important, but it does complete the story. How do you actually form the hydrogen chloride to begin with there? And now you get the ester, nice and happy there. Okay. Describe nucleophilic additions and then elimination. When they say describe, it could mean draw. Okay. Compare with the older syllabus. In the older syllabus, they don't really describe that. So, you know, it's just one of those things there. Okay. Happy? Okay. All right. Now,
and if they asked us to write the mechanism, do we just state that which lone pair attacks which atom and which so on? If written, not drawn.
If they give you lines, they expect you to write some stuff, right? But if they give you space, do you think you write when they give you some space? So most likely it will be draw, and then they will say include non-pair dipoles, curly arrow, and things like that, right? So it should be quite obvious. It should be quite obvious if they want you to write or draw. It should be quite obvious.
Okay.
All right. Okay.